Welcome and hi everyone. Today I will present my STA416 project titled The Relationship Between Delivery Distance and Food Delivery Charge Among GrabFood Orders to College Kerawang UiTM Kuala Terengganu. And this project studies how distance affect the price we pay for GrabFood delivery. And hi, I'm Dato' Atira binti Wazmi.
Hi, I'm Nuremina binti Kawasan. On this slide, I introduce the topic and why I choose it. Students at UiTM Kuala Terengganu, especially those that living in the College Kerawang, use GrabFood a lot because it's convenient when the campus food is limited or far. But many students notice the delivery fee is sometimes different even when the distance looks similar. So the main question here is, doesn't the delivery distance really affect the delivery fee? The study looked at the relationship between distance and delivery charge for GrabFood order going to the College Kerawang. For the motivation, students often face inconsistent delivery fees, and since most of them have limited budget, understanding how the price is calculated can help us plan better. This project also uses the real data to understand how the GrabFood price behave in our area.
So the objective of this project are simple. First, to identify the average delivery distance and charge among GrabFood orders to College Kerawang. The second, to find the correlation between the two variants. And the third one, to develop a regression equation to predict delivery charge based on the distance.
On this slide, I explain the dataset used in my project. I collect 30 GrabFood delivery records that were specifically delivered to the College Kerawang. For each order, I recorded two important values, the delivery distance in kilometer for X and the delivery charge in ringgit for Y. This dataset helped me analyze whether the distance really affects the price.
Next, this slide shows the data summation that we use to calculate the correlation and regression. So we have collected 30 datasets from GrabFood apps and we have total for each variable. Summation X is the total delivery distance from all 30 GrabFood orders, which is 296.1. Summation Y is the total delivery charge, 227. Summation XY is the sum of each distance multiplied by each delivery charge, which is 3039.75. Summation X squared is the total of all distance values squared. Summation Y squared is the total of all delivery charge values squared. These summations are important because they are used in the formulas to calculate the slope, intercept, and the correlation coefficient. In simple words, this slide shows all the common values we need before we can do regression and correlation analysis.
This slide shows the scatter plot for the distance and delivery charge. Each dot represents one GrabFood order. As we can see, the dots form the upward trend. This means that when the delivery distance increases, the delivery fee also increases. The pattern is very clear and almost from a straight line, which already tells us that the relationship between distance and charge is strong. The scatter plot is useful because the visual confirms the positive relationship before we can even calculate correlation or regression. On this slide, I explain how they calculate the Pearson correlation coefficient R using the formula. In the numerator, I calculate 30 multiplied by summation xy, then subtract summation x times summation y. Next, for the denominator, I calculate two separate brackets. The first bracket is n multiplied by the summation of x squared minus the square of the summation of x. And the second bracket using n multiplied by the summation of y squared minus the square of the summation of y. Then I multiply both brackets and took the square roots. After completing all the calculations, the final result for the correlation coefficient is R equals 0.9945. This value is very close to 1, so the relationship between delivery distance and delivery charge is extremely strong and positive. This means that when distance increases, the delivery fee also increases in a very consistent pattern.
On this slide, I explain how I calculated the regression line using the summations values for my dataset. First, I used the formula for the slope B as shown in the slides. After calculating, I got the slope B 0.7781. This means that for every 1 kilometer increase in distance, the delivery charge increases by about 78 cents. Next, I calculated the intercept, which is A using the formula. After substitute the values, I got a negative 0.1131. This small negative number happens because of the dataset pattern, but the overall relationship is still accurate. So, the final regression equation is y equal to 0.7781x minus 0.1131. This equation can be used to predict any delivery charge based on the distance. Here is an example of how the regression equation works. If the delivery distance is 22.5 kilometers to College Kerawang, I substitute add 22.5 into the equation. So the calculation becomes y equal to 0.778 when multiplied with 22.5 minus 0.1131. And after solving it, the delivery charge is about 17 ringgit and 30 cents. So this shows how the equation can help us estimate delivery fees for any distance. Here I explain the slope of the regression line. The slope is 0.7781, which means that for every 1 kilometer increase, the delivery charge increased by about 78 cents. Because the slope is positive, it shows that the further the rider has to travel, the higher the delivery fee becomes. This matches how GrabFood pricing works in real life. Next, I calculated the coefficient of determination R-squared. The correlation value RP4 is 0.9945. And when we square it, we get 0.989. This tells us that 98.9% of the change in delivery charge can be explained by delivery distance. So almost the entire variation in price is mainly due to how far the restaurant is from College Kerawang. So in conclusion, the results show a strong positive relationship between delivery distance and the GrabFood delivery charge. Longer distance clearly lead to the higher delivery fees. So the regression models give a good prediction of a delivery charge based on the distance. And lastly, the high correlation value, which is 0.995, shows the results are very reliable.
Lastly, for the future work, collect the real delivery data strength the finding, include other factors such as weather, peak hour, and schedule pricing. Compare results with the other delivery apps like Foodpanda or Shopee Food. Test whether pricing stays the same for different area or distance. That's all from us. Thank you. Bye.